Hello, everyone. I want to talk about the first exam and what you can do to get ready for it. The exam date is going to be March 7th. It will be during lab time. What this will look like is we will have the exam at the start of class, and when we're done, we will have a shortened lab with the remainder of the time that we have that day. So we'll go through these listed things, course objectives, exam logistics, the focus of each module, and what you can do to prepare for this exam. These are the course objectives as listed on your syllabus. I am not going to read through each of these. You can read through them on your own. But just in terms of matching up what's on the syllabus to what we are covering on this exam, some of these will come back to in more detail on a later exam. I did want to point out one thing, is that we are only looking at the heat equation for this objective R. We'll do the rest of this in a later chapter. Okay, so some logistics in terms of what to expect on the exam. You will be provided with a periodic table. You will also be provided with a list of polyatomic ions. So you'll have those resources available to you regardless of what else happens as part of the exam. You need to bring three things. You need to bring a pencil, a Scantron form, and most important thing is a calculator. The exam is written with the expectation that you have a calculator. If you are planning to do long division in the margins of your exam, you probably will not have time for that. There are lots of calculations you will be doing, and the exam is not on your ability to do the arithmetic. It's the ability to set it up and use your calculator to do it. So please, please, please remember to bring your calculator so that you can get the exam done in the time that's available for it. If you would like, you may also bring a 3x5 note card. Now, I don't just say 3x5, I have units here, so 3 inches by 5 inches, okay? So remember the units. You can have a 3x5 card. You can use both sides, is fine for that. And you can have whatever you think would be helpful on that note card. Do not have, of course, you could have a cell phone around for emergencies, but I shouldn't see it during the exam. So if you do have a cell phone, make sure that it's put away where I don't see it and it doesn't disturb anyone else while you're taking the exam. Some ideas in terms of what to expect on the material on the exam. The non-multiple choice questions should resemble questions you have already seen on things like the worksheets. So you shouldn't see anything unsurprising on that portion of the exam. It should be very similar to things you have seen on those worksheets before. However, there will also be a multiple choice portion which might be a little bit different. You might see things there that don't resemble things you've seen before. Now, don't worry about that too much in terms of that being something that will cause you to fail the exam. The multiple choice questions are going to be curved. They might be very challenging in some cases, but it will all be curved. So, for example, if the average of the class on the multiple choice questions is, say, a 50%, and that would not be unlikely, but the average of the class on the non-multiple choice questions is an 80%, then if you got a 50% on the multiple choice, it would actually be an 80%. So when I curve the exam, so I will curve the multiple choice. I won't curve the non-multiple choice, but I will curve the multiple choice. When I curve that, the curve is so that it matches the non-multiple choice part of the exam. The reason I do it this way is because I want you to work together. I want you to collaborate with each other. I want everyone to do well. When you have a typical grade on the curve, it really, what it's encouraging is it's encouraging you to be competitive with each other, and to maybe, you don't have, it's not so much how well you do, it's how well you do better to everybody else. I don't want to encourage that mindset. I want you to work together. So the way this one works is that if everybody does good on this part, if everyone's doing good on these ones that resemble things you've seen before, then everyone will do well on this part, and everyone's going to do well in the class. So although these are challenging questions, I don't want you to be discouraged about your ability to do well on the exam in spite of that. The reason I do have these questions is that at some point you're likely to have some kind of standardized entrance exam to some field of discipline. They aren't necessarily the best way of determining things, but it's a way that is often used. So I want you to have experience with that before you get to that point. So this is a way of doing that where it is sort of something where there is some amount of it will affect your grade in some way, but it's not kind of a pass-fail thing, because it is curved and because it is only 20% of the exam. Now your final exam will be 100% multiple choice, so we're kind of getting ready for that with these exams, and your next one will probably be a bit more than 20%. But the idea is to kind of slowly work towards that throughout the course of the semester. In terms of the modules that we covered, these are the percents of the exam to expect on that. So around 16% for most of them. Module 6 is longer, so it's about 33%. There's a lot of material in Module 4, so that one is a bit more. And we did cover a bit of that, especially the naming in the lab time in a bit more detail. But pretty much equally distributed based on the amount of time we spent on them during the semester so far. Okay, so let's look at each module a little bit in terms of what were the main ideas from that module. For Module 2, we had a lot. Actually, there's a lot in Module 2. So we started with scientific notation. We looked at significant figures. There are two things you need to do here. If you have a measurement, you need to be able to count the significant figures in that measurement. And then if you have if you need to perform a calculation, you need to have the correct number of significant figures when you perform that calculation. Okay, so two ideas there with significant figures. Unit conversions are a big part of the whole course, and we first saw them in Module 2. Part of this is recognizing the units. So when you see, for example, kilogram, what is that measuring? You need to be able to recognize them. And then using the SI scale, convert between different units. So between, for example, kilograms and grams. So we had five prefixes you needed to know, and that meant not just that you know what the prefix is, but you're able to use it as a conversion factor. Definitely I would recommend practicing that and perhaps including some information related to that on your note card. You do want to have a good sense of which numbers are bigger, or which prefixes are bigger or smaller here, so that when you do the calculation, you'll know if your answer is going to make sense. And then we also looked at units raised to a power here, so things like volume and area are places where that would matter. In Module 3, we continued some of the ideas we looked at in Module 2. Specifically, we looked at the calculation of density, so this was in Chapter 2 of your textbook. And then we looked at other conversions such as temperature and the use of the heat equation. With the heat equation for the exam, unlike what you saw on the lab, you will have only one heat equation. in a problem. So instead of setting one heat equation equal to another, that's a lot to do on an exam in a short period of time. You will just need to do one heat equation by itself. Okay, so it will be a little bit simpler than what we saw in lab. Also, we had some qualitative stuff, so you want to be familiar with the scientific method. And then we classified things like matter. So we had 4 categories of matter: elements, compounds, homogeneous mixtures, and heterogeneous mixtures. We classified properties of matter, transformations of matter, and energy. So be able to do any of these classifications as well. Module 4 was a lot of information. We had essentially 2 chapters of your textbook here that we went through pretty quickly. So you want to be familiar with subatomic particles, so the protons, electrons, and neutrons. You want to know what mass number, atomic number, and atomic mass are, how these numbers relate to the subatomic particles. We had a variety of ways of looking at this. We had some tables we filled out. And then also you want to know properties specific to each of these particles. On the periodic table, you need to be able to understand the periodic table. You will have one to look at, but you need to know what it means. So you need to be able to find information about specific elements on the table. So things like the atomic number, the atomic mass, the symbol, all of those are on the periodic table. Where are the metals and nonmetals? What are properties of metals and nonmetals? What are the groups and periods? And then there were some, I'm calling them special groups of the periodic table. So groups with special specific names, so know what those parts of the periodic table are. For compounds, so this was about atoms and elements. For compounds, you need to be able to classify them as molecules, ionic compounds, or acids. And in doing so, when you make that classification, that is the first step in naming a compound. So you also need to be able to predict the formula if you know the name of the compound, or name it if you know the formula. So given the formula, find the name. Given the name, find the formula. You need to go in either direction, and you need to be able to do that for covalent, ionic, or acidic compounds. We spent quite a bit of time looking at this with an activity during lab time. So I think this will be a major part of this that you would need to be able to do. In Module 5, we introduced the mole concept. And there's a lot of different conversions we looked at, and so we're again applying this idea of conversion factors that we saw first in Module 2. So you need to be able to convert between atoms and moles, between moles and grams, and these you need to be able to do in either direction. You need to be able to even maybe go between atoms and grams, so kind of combining these ideas. What we're seeing as we introduce the mole concept is that it is a concept. It's not necessarily a set procedure that will be the same every single time. So you want to be able to use the concept of a conversion factor to do this. Okay, so these conversions are based on the conversion factor concept, not based on I memorize, I do it this way every single time. It will change from question to question what that could look like. We also looked at how we can find empirical formula from percent composition or vice versa. So you need to be able to go from empirical formula to percent composition or from percent composition to empirical formula. And then we talked about the molecular formula as well. So finding this if you know the empirical formula and you know the molar mass. Okay, so these were the ideas from Module 5. Module 6 was the longest module. We spent 2 weeks on this. And Module 6, as we'll see, the mole concept is again very important here. So we were looking at chemical reactions. So you want to be able to balance an equation. You want to be able to classify reactions as we had 4 types of reactions. So you want to be able to put it into one of those categories. For double replacement reactions, we wanted to be able to predict the result of that. Now, just a reminder, we're not going into as much detail here as your textbook does in terms of understanding the nature of the aqueous environment. So what is aqueous, what is solid? You don't have to do that part of it. One thing I should mention is that on your practice exam, you might see some of that. You won't have to do it right now. It will come up on the second exam. So just be, you don't have to go into as much detail there, just as a reminder. And then in Chapter 8, we introduced stoichiometry, where again, the mole concept is very important. So there are numerous possibilities of how to use the stoichiometry concept. And again, you want to understand the concept, not memorize each possibility, because we'll get even more possibilities in later chapters. You need to be able to convert between moles of one thing and moles of another based on the balanced chemical equation. So you're using the stoichiometric coefficients for this. Mass to mass. Now we don't have a direct relationship here. You have to go from mass, you have to convert with the moles, so between moles, and then mass to moles to mass as part of that. There are other possibilities. Again, there's numerous ways to do this. You want to focus on having the units do the work for you here. So it's really about the concept, not about following a set procedure every single time. You really want to master the concept here. We also looked at the limiting reagent concept, where you're doing essentially two stoichiometry problems to make a decision on what is a limiting reagent, and you could be asked to find the amount of a product, or you could be asked to decide which reactant is the limiting reagent. We also looked at the percent yield concept. So here you are taking the actual result of a reaction and comparing it to what you would predict based on your initial amount. The biggest thing here is that as you're doing this, you want to be comparing the same things, comparing product to product each time. And then finally, enthalpy. So be aware of some of the kind of qualitative aspects of that, as well as the conversions that we looked at. Okay, so how do you get ready for this exam? These are my recommendations to you in terms of how to prepare. First of all, make sure that each worksheet we've had so far that you're able to master each one of those. I know as we went through really quickly, and it's possible that some of you didn't get every single concept down each week. So go back, look at those worksheets, figure out anything that you weren't able to figure out before. Make a note card for yourself. So what were the important ideas on those worksheets that maybe you would want to have a record of as you go into the exam? The biggest part of the note card, I think, is the act of making the note card helps you realize what's important. What are the few things you can write down on a note card? So that act itself, I think, is often more useful than the note card is on the exam. Take the practice exam. I would recommend taking it as if it were an exam. So this means that you don't have other distractions. So, remember how I had you set up certain times of the week where your focus was preparing for this class. Take some of that time. Don't have anything else kind of distracting you, anything else in the background. Take 75 minutes, go through the practice exam, take it, see how you feel about it when you're done. Whatever parts of it, when you do that, you get a sense for these are the things that maybe I need to focus on some more. If you do it that way, as opposed to doing it, say, with your book open where you can go and look things up if you need to. You get that sense of taking it like it were an exam. And then when you take the real exam, you'll have, I think, often have less anxiety because you've been through that already in the practice. And then you'll know what things to go back and focus on a bit more. At any point during this process, so whether it's going back to the worksheets, whether it's on the exam, practice exam itself, feel free to ask any questions to help prepare for that. There is a discussion board specifically for exam number 1. And unlike some of the other discussion boards, you will get graded simply for your participation. So there's not a wrong way to participate in this discussion board. Do whatever it is you think is helpful to get you ready for the exam. Some things that could happen out of this, if there's enough interest in particular questions, whether they are from the practice exam or whether they are from one of the previous worksheets, I will go ahead and make a video answer key for the ones that seem to be the most useful to people. So if you have particular questions about particular things, ask them on that discussion board, and I can go through and do those specific things. So you have those answer keys. And then also see a tutor. So we do have tutoring times available in both locations. Set aside some time, see which times match your schedule. Come in with questions prepared ahead of time. So if you show up and say, I just don't know how to do it, that doesn't give the tutor a lot to work with in terms of what they can offer you, what kind of help they can offer you. So I would recommend doing this after you've already tried to engage with either the worksheets or practice exam. Or you can come by my office hours if that is a convenient time for you as well. This week, there's not really any new material. It is kind of up to you how much time you want to put into this preparation. My hope is that you put in enough time that you can do excellent on this exam. So please send your questions, and that is all I have for now.